Let us try to understand how the intersection of planes is related with their normals. Now, this concept is very important to understand since these days you find in competitive examinations some multiple choice questions. So they are not really interested in finding the answer, but they are interested in matching the answer, right? Now, here, what we can do is if we get an idea about at least the type of intersection from the normals themselves, we can make a quick choice and save a lot of time getting the right answer also. So this is kind of very important. Based on that, what I've done is I've taken a couple of videos here where I will kind of discuss with you how normals are related with the intersection of planes. So this is for two planes, right? As you know, two planes could intersect in a line. They may be parallel, in that case they don't intersect, or they may be coincident, that means they intersect in a plane itself. So in two planes there are two different conditions which we can consider. So the question here is, what can you conclude about the intersection of two planes if their normals satisfy n1 dot n2 equals to 0? And the second one is, two planes if their normal satisfies that their cross product is 0, right? So what do you conclude in both these cases? So let's take them one by one. I know for most of you it is quite obvious, but let's get into details, right? So when I say n1 dot n2 is equals to 0, what I'm trying to say? I'm trying to say that magnitude of n1 times magnitude of n2, cosine of angle between them, is equal to 0. That is what I'm trying to say, right? Now that implies, since the normals are not 0, so the angle cos theta is 0. So cos theta is 0, that means this implies that theta equals to 90 degrees, right? That means the planes are perpendicular, right? It means perpendicular planes. And since the planes are perpendicular, they will always intersect in a line, correct? So that means the intersection is a line, right? So here the intersection is a line, correct? So we get, for this first case, the intersection is in a line, correct? So that is the case and it is always true. So this is for the first case, right? Let's go through it. So n1 dot n2 is 0. It implies that their magnitudes times cosine theta is 0. And that implies, since n1 and n2 are not 0 individually, therefore cos theta should be 0, which is 0 only when theta is 90 degrees. Or the normals are orthogonal, right? They are perpendicular. Since the normals are perpendicular, the planes are perpendicular, right? And therefore, they will intersect in a line, correct? So this is the first case. And the second one is in a similar fashion. We'll do n1 cross n2 equals to 0. So that implies that magnitude of n1 times magnitude of n2 times sine theta, right? Cross product is sine theta equals to 0. And that means sine theta is 0, right? So when is sine theta 0? Sine theta is 0 when theta equals to 0 or 180 degrees, right? So it is 0 when it is 0 or 180 degrees. Let's put that phrase, right? So that is the condition. So in this case, we have two conditions, right? So in this case, we have two conditions. That is when the planes are parallel, right? So the planes could be parallel, or planes could be coincident. So in case they are parallel, in that case they do not intersect, correct? So they do not intersect. And if they are coincident, they intersect in a plane, right? So they intersect in a plane, correct? Now how can you find which one is true out of this? So you can find whether they intersect or they don't intersect, or whether they are parallel or they are coincident, if the whole equation of plane is a scalar multiple, right? So if the whole equation is, well, in both cases, in both these cases, what we know is that that means n1 equals to k times n2, right? We know that. But if the whole equation of a plane, that means is they are coincident if pi 1 equals to k times pi 2. Do you understand? The equation of plane is itself a scalar multiple. In that case, they are coincident, right? So that is how you can check and verify quickly whether they are coincident or parallel. So that is not an ambiguity at all. So here we have two cases, right? So two cases depending on whether I should now write pi 1 equals to k times pi 2 or not. If it is so, then the intersection is a plane, right? But if pi 1, the whole equation is not a scalar multiple of the other equation, that means they are different planes, they are parallel, right? So that means they are parallel planes, right? Parallel planes. So no, do not intersect, right? Do not intersect. Is it okay? So that is how we can actually summarize or conclude from these given questions, correct? So even those students who are doing descriptive or short answer questions, for them it is important from communication point of view. So at times you need to reason out. So this is a good reason, okay? Now let's move on and understand what happens to normals in three planes, okay? Thank you.